morning, everybody. Welcome to Tippett's Physics. What is crappin'? It's currently 3:06 a.m. and we're going to do some acceleration practice problems together. These problems came straight from the regents, and we will go through them step by step on how to solve them. So let's go through the first one. An object accelerates uniformly from 3 meters per second east to 8 meters per second east in 2 seconds. What is the magnitude of the acceleration of the object? So the first step is to write down our knowns. We're given the initial velocity is 3 meters per second. The final velocity is 8 meters per second. And the time is 2 seconds. And we're asked to find the acceleration. So, after we write down our knowns, what we're going to do is look in our reference table under the mechanics section. Let me move it up here for you. Okay, so we look at the acceleration formulas. That's the bottom four. And we want to find one that has VF, VIT, and A. And it looks like this one right here. VF equals VI plus AT. And we're solving for acceleration. So we want to get that by itself. We'll subtract VI and divide by T. VF minus VI over T equals A. And then our last step is plug and chug. So VF, 8 meters per second, minus 3 meters per second, all over 2 seconds equals A. 8 minus 3 is 5. 5 divided by 2 is 2.5. So the acceleration is 2.5 meters per second squared. Alrighty, so here's our second problem. If a car accelerates uniformly from rest to 15 meters per second over a distance of 100 meters, the magnitude of the acceleration is. Again, we're always going to write down our knowns. So accelerates from rest. That means it's not moving initially. So VI is 0 meters per second. To 15 meters per second. So VF, 15 meters per second. A distance of 100 meters. So D is 100 meters. And we're finding acceleration again. So now we look again at our reference table. What has VF, VI, D, and A? That would be the bottom one. VF squared equals VI squared plus 2AD. VF squared equals VI squared plus 2AD. And again, we're still solving for acceleration. VI is 0, so we're going to get rid of that right away. We want to solve for A, so we'll divide by 2 times D. We're left with A equals VF squared over 2 times D. And then plug and chug. A is 15 meters per second squared. Make sure we're using parentheses. Over 2 times 100 meters. We do that in our calculators and we get acceleration is about 1.1 meters per second squared. And always box our answers so people know where we're writing. Alrighty, last problem for the morning. It's almost 4:38, getting past my bedtime. So let's see here. A car initially traveling east with a speed of 5 meters per second is accelerated uniformly at 2 meters per second squared east for 10 seconds along a straight line. During this 10-second interval, the car travels a total distance of, so we're finding the distance. Notice that the acceleration and the velocity of the object are in the same direction, so that means it'll be speeding up. So let's write down our knowns. Initial velocity is 5 meters per second. The acceleration is 2 meters per second squared. And the time is 10 seconds. And we're asked to find the distance. So it has VI, A, D, and T. We look at our reference table. And it's D equals VIT plus 1/2 AT squared. Okay, and distance is already by itself, so all we have to do is plug and chug. So D equals VI, 5 meters per second, times T, 10 seconds, plus 1/2 acceleration, 2 meters per second squared, and I can't fit it all in here, sorry, times T squared, 10 seconds, quantity squared. We do this in our calculator and we get the distance is 150 meters, which in your question or in the answers is 1.50 times 10 to the 2 meters. All right, that's it for me this morning. Good luck with these problems. I hope you found them useful. See ya.